All right. Well, hello everyone. Welcome to Intro to Computer Science by the Trans Academy. Um, so I guess a little bit of background about myself. I guess to build a bit of context, I'm a software engineer of. Actually, did I set everything up here correctly? Apologies. I'm a software engineer for about a decade. I have a degree in computer science, and yeah, I'm a trans woman. I go by she, her. Last year we taught last year Epple and myself taught the first course at the academy for the computer science classes, and this year just me teaching it on this one, at least for this series. For those who this is the announcement, but for those who are not aware, this is a 8-week series. So this one's just the introduction. We'll touch some basic concepts on some programming and the like, but most of this is just going to be industry questions. So please, well, industry questions and background. So please do feel free to ask questions at any point during this, and I'll happily provide some information on it. Also, I apologize. My full body tracking is broken today. One of my trackers decided to die right before I got in VR. I love technology. So yeah. So I guess to start, right? What do these have in common? So what do these have in common? So let's see. So we got VR chat. We've got the moon landing, and we have a quite comical search here of on Google of, is my blah eye cheating on me with my plushies? What these have in common? Well, they require code, everything, and all these, at the end of the day, do relate back to computer science, right? So, at a very high level, and I kind of like the analogy of computer science is about as much about computers as astronomy is about telescopes. So, what computer science is it is, say, computers and computational systems, but specifically it's how they modify data, how they present it, how you work with that data to present something such as a workable program or a virtual experience or a web page, right? Or a mobile app. So, and for me personally, this was one of the reasons I got into programming originally, and ultimately one of the reasons I got into computer science was I got into computer science because I was because I didn't exactly feel like I fit in the real world for a very long time, so I learned to create virtual ones. So that's one of the cool things about it, is you can shape the world around you, the physical and the virtual. So all right. All right, cool. So what are the goals for this course? So full disclosure, this is not a comprehensive crash course on computer science. That would take multiple years and hundreds of hours, which nobody here has any interest in doing. At least not in the academy right at this moment. So our goal was basically to provide a basic concept, a high-level overview of what is involved, right? Or specifically, what is computer science, right? So we'll be touching on things such as, at a high level, be touching on some things such as particular objects, classes, data structures. Those are some of the big ones. Those will be touched on later in the lesson or later in the series. And we'll also be touching on things like that are a bit more high level, such as how you structure your program. And we'll be primarily working within Python for this course. Myself, I know of more than a few different languages. So if you have a question about something and you're trying to figure out how to apply it from another language, by all means, feel free to ask.
My friend
Better
requested to join the group.
better chance than not that I can probably help convert some. If not, someone else in the group will happily do so. So the other goal here is to offer a roadmap for future study, right? So by giving a foundation on what is involved from a theoretical perspective and what is involved from a high-level programming perspective, it gives a foundation to build upon. The other thing we're doing here is offering resources. So what I mean by this is, at any point, if there are, so both within the classes themselves and materials will have external resources and the like, as well as if anyone here has any questions on specific concepts or specific areas, please feel free to ask in the Intro to CS channel, and happily find some and link them to you. For perspective, I'm 29 years old. I'm a self-taught engineer originally, and I've been programming since I was 14 years old. So, yeah, I mean that's a bit of context on there. The reason we're doing this in VR for this portion is because this is a much better forum to present the information as well as to ask questions and the like. So we do have a weekly Discord session as well, which will give where we will actually sit down and physically write code and program and all that. So what this class does not cover is it's not comprehensive coverage to CS concepts. It's high level. And it's not going to go super in depth. If you have a question that's in depth, like let's say you're coming in here with some existing knowledge, happy to answer, but that's not the primary direction of what this course is offering. And I guess to stop here for a second, does anyone have any questions so far on that? All right, that works. I'm going to apologize if my voice is messed up. I've had a bit of cold the last week. So, a little bit about the computer science industry. It's very diverse, and large part of the reason it's diverse is it permeates a very large amount of areas of our life. So, to give some examples, right? Like there is software in the medical world, there's software for vehicles, there's software for things like VR, there's software for websites, there's a very long list, very long variety of areas and niches and technologies, which means, well, it has a lot of opportunity in it. So a couple ways that people have made money in the industry, and this is by no means an exhaustive list. And for the record, if you're just here because you want to learn how to program, and you don't really care about this at all, that's completely fine. Actually, why I originally got involved in programming to begin with. I had zero interest in making a dime from it, but hey, giving us context here for anyone who is curious. So common way for people to do that is they'll be employed, whether by a company, a contract, or self-employment. They may also be involved on things like startups, where they're going through and creating new products and new lines and the like, whether as a CEO or as someone who has a percentage of ownership in the company. They may also just be writing cool things on the internet and taking Patreons, or taking a Patreon donation. Those are some of the main ones. Likewise, not an exhaustive list. So, like for example, specializations in computer science. So, okay, well, my hand just broke. Okay. So, specializations in computer science, you have web, you have data science. You also have things like cybersecurity and game development. Mobile is still an industry that has a very large number of developers in it, as well as AI. Love it, hate it. It's an industry that has more than a few people in it. 3D/VR technologies, such as us here in VR chat right now, and operating systems. These are some main ones. There are a large number of niches, right? So yeah, there are a large number of niches, and this is not going to be an exhaustive list. Okay, so I may have gone through this slightly quick, but does anyone have any questions so far? I believe the next slide. Go for it.
I don't have access to the computer science channel on Discord. Should I?
You're probably missing a role. I think it's the intro to CS. I believe it's the intro to CS student role. Is that what it is called currently in the system?
Something just popped up.
Yes, it's intro to computer to CS student.
Thank you.
Okay.
I see a question. My friend is thinking about college for a CS degree. Is that worth it? So that's a great question, especially considering the number of tech layoffs there's been in the last few years. So in my perspective, the answer to that would be yes. Though I definitely won't lie. So in past years in the industry, it was definitely less competitive than it is now. It has continued to get more and more competitive as more and more people have got into it. I think it's in the last couple of years that it's finally gotten to the point where the number of computer science graduates is even started to get close to the number of positions that open. It's definitely still worth it, and if you genuinely do have an interest in it and you really enjoy it, more likely than not, you'll be fairly good at it. Most of the people in the industry I've met do it because they love the actual trade, they love the technology. And most of those people, in fact, the bulk of those people have no problems finding work. So I'd say it's worth it. I would say it's probably not. I would say it's probably not worth it if you're wanting a degree that's, I'm just going to go here, learn this, and never brush up or update. You're completely fine. It's difficult to type on on those keyboards, on the virtual keyboard. It is entirely a situational thing. So I have met some engineers who have no formal computer science education and they're completely fine. I've also met people with masters, and I've worked alongside more than a few on both sides of that scale. It depends. Yeah, like basically, from my perspective, is if you have a number of years in experience already, as in you have worked for a company, you have a track record of places you have been at a certain point, they don't care as much about the degree where you came from. But if you don't have that degree, it can be extremely difficult in the current industry to get that first position. That used to be a lot different in the past, because in the past you had options of going to like a boot camp and the like, right? Because there was such a shortage of computer science graduates. So companies would start going for boot camps and the like, but that's not the same situation we're in right now. That being said, I say this in general, there are exceptions to every rule. Like, I have been involved in the open source space since I was 16 years old. I am intentionally not going to say some of the things I was involved in because I'd like to not dox myself, but back then I was doing work fairly openly, and I had my first position whenever I was, 18. Did not have my degree at that point. So there are definitely exceptions for everyone. It just is much, much harder. All right. All right. Feel free to interrupt me if I missed any questions, but I'm going to jump to the next slide. Really good questions, by the way.
There's actually someone from the Discord.
Oh, go for it. What do we
This
got?
person has been. If I haven't been in school for 5 years and I'm returning to university for a comp sci degree, how do I get myself back up to speed and reduce the struggle of catching up with the rest of the class? Basically, how to catch up with others on programming.
You don't really need to. If you're going in for computer science, in a lot of cases, many of your peers aren't going to have any pre-existing knowledge. So at some universities they will, but oftentimes they won't. Like whenever I went to school, for computer science originally, a lot of my peers had fairly minimal programming experience to begin with. In fact, it was actually kind of unusual because it's kind of weird. Like, if you go for a computer science degree and you have even the smallest amount of existing programming knowledge in theory, you genuinely are significantly further ahead on your classes, and they'll be much, much easier for you just because you've, done it and you built it before. You're also likely going to understand why you're learning the things you are, rather than just the theory itself. Like, sometimes with university, it's not exactly like it will be presented as, here is the theory on what I'm teaching. Now we're going to apply the code to it. But if you've already been writing the code for years in your spare time, or months or weeks, then you understand why the theory that is sitting right in front of you is important, and you're likely to take a lot more of a grasp of it. So I guess to give a short answer to that, or to give a very long-winded answer to that, I would sit down, I would do some projects. I would try to build something that you want to use, right? Build something that you're passionate or interested about, right? That could be an app, it could be a website, it could be, I mean, heck, it could literally be anything you want. Like, I personally write home automation code for fun in my spare time. That's how I keep my skills sharp. Just whatever you want to do. But yeah, just sit down, code something, practice, and you'll be further ahead than most of your peers when you start.
Thank you.
Anytime.
I have one more question, kind of on the side of
Yeah,
of
go
that
for it.
one. So does that mean it's more? It seems like it's more important to understand the theory and not the specific. What's the word I'm looking for? Like it doesn't matter what language. It's more important the theory.
Mhm. Yeah, absolutely. It's more important to understand. Yeah, methodology, exactly. It's more important to understand the fundamentals and the foundation of what you are working in, rather than understand the exact nuances of a language, right? Like, the reason that we use Python here, right, is because it's a fairly accessible, fairly standard language. It doesn't have a lot of weird nuances or the like, which makes it very good to teach with. Personally, I've written code with Python. I've written code even professionally with Python, but the bulk of the code I've written isn't even in Python. And my first language that I actively wrote in was C and C++. 10-something years ago. I also used to program in PHP. Like, the thing is, once you understand the fundamentals and once you understand the base, like how it all works together, you just look at it, you're like, language, these concepts. Library, these concepts. And you can just adapt them and work between them. Takes a little bit of time, takes a little bit of practice to do that, but yeah, exactly. That's why it's so important, because if you understand the fundamental on it, the programming's easy to pick up from there.
Okay, thank you.
Anytime. Most of what we're going to be touching on here is we will be touching on some higher, high level CS theory, but we are going to ultimately be touching a fair bit on the programming concept itself. We're not going to get super in the weeds on it, but by all means, if anyone is curious, wants to dig further into it, highly, highly recommend. There's only so much we can put in an 8-week course that meets for a couple hours a week. All right, so I believe this next slide is where we start getting to the fun stuff. If it loads for me. Previous slide, next slide. Unable to load image, download error, cannot resolve destination host. Oh, lovely. I'm going to click the next slide, and hopefully that wasn't important.
I can see the screen.
Which means it's probably an issue on my side.
See a slide that says programming environment.
It's talking about the programming environment.
Well, I'm going to cheat. I'm going to open an overlay then. And because the slides are still in order, and I will make this work.
Adapting.
So it's going to work assuming I'm still logged into my Gmail on this machine, which... Oh, I know what's wrong. So, fun thing, if you ever decide to run your own DNS server, don't use it in a setting like this. Because mine just crashed, and that's why I can't access, and that's why it's not downloading the image. Let me just switch back to the public DNS. I'll just change this back to automatic real quick, and that shouldn't kick me. Click here, and yep, that's exactly the problem. Okay. Previous slide, next slide, and now it runs. Cool. I'm so sorry. Genuinely. This is what happens when you decide to run a server cluster in your home and you don't test changes before something important. So, programming environments. So, we're primarily going to be working with Replit. In fact, once a week there is a little worksheet that's handed out. This is, of course, optional to complete. No one is grading anyone here. Like, well, we are going, like, myself and Lucian will take a look at it and just verify that, like, you had the right idea on what's going on. But end of the day, it's completely for your own benefit. So that'll be going out later tonight. I'll be sending that after this, probably a couple hours afterwards, and it'll be sent as a Replit link. So for those of Replit is a for those who are not familiar, Replit is a free online IDE or interactive development environment. So it has an included text editor where you can actually edit the code, as well as the ability to actually run the code from there. This will also provide a sandbox. So in the event you receive any code from a colleague, or I guess in this case, a classmate, and you want to take a look at their code, you can just open it in Replit. You don't have to worry about anything funky going on with your machine. So provides a really good way because literally just I just share a link in the chat, and you log into Replit, hit fork, and you can create a copy of the worksheet for you to edit, and whenever we submit, we just post them into a thread. But yeah, so that's why we're using that. It's to make it easy for everyone to get started and set up. So there should be an image on here. Okay. Well, this is a small problem. Okay, so I guess let's get started here. So your first program is a hello world program, typically. So I'm going to apologize completely because something has gone very funky with this, and I'm not exactly sure. Oh, okay. I'm going to have to edit this next time we teach this. So your first program, traditionally in programming, it is a program called a hello world program, and all it does is it prints the text hello world to the user, right? So video's on the next screen, and this might take a second to load, but in the case of Python, it's just print and the text hello world, or hello Apple here. Apple is one of our other computer science instructors, and Very sharp individual. So, context on what this would do, right? We can extend upon this a bit. So, for example, print hello apple here, smiley face. Is it going to print hello apple here? Print I'm going to scream is going to print I'm going to scream. And print ah is going to print ah. So, we're going to do an example real quick on some addition and subtraction. So, in this case, there's going to be some addition here. Is this visible to everyone currently? Or is this too small?
Kind of small for me back here.
Then I'm gonna opt to skip the
It's,
video
but
because I'm gonna opt to skip the video and myself for next time because we have the same content on the next slide. So, quick example of some what we refer to as operators, right? So, we have an addition operator, a subtraction operator, a multiplication operator, and a division operator, right? So, in the case of value, so in this case, we're wanting to set the value of value. Those who are curious, this is functionally the same as algebra. So if you were to replace, like for example, x equals y plus 2, the equations that we were all made to solve in school, same concept in here. So like for example, value equals 3 plus 4, value is going to equal 7 at the end of this. And for and we're going to end up with print value. So the key detail here is this little plus sign. So for example, if this were, we could have any value here, right? So if this was 7 plus 3, this would be 10, right? An example of subtraction. So we have value, and we're going to set to 4 minus 3. Okay. So that is going to make this equal 1. When this prints, it'll be 1. For multiplication, it's going to be 3 times 4, which will be 12. And for division, it is going to be 4 divided by 4, which is going to, interestingly enough, it's going to equal 1.0. Let me see, are we going to explain this here? So, this might actually, so for anyone who wants to do a little bit of digging or wants to inquire, and I'll explain this on the, whenever we do the workshop, but there's a reason that it outputs 1.0 as opposed to just 1. And I'll leave that as an exercise to anyone here. So, this slide is wrong. This slide is wrong. This is last year's slide. So, workshops are Thursday. My apologies. I'll put the updated time in the intro to CS chat. But yeah. Do we have any questions on that? Yes.
I have a question.
Yeah, go for it.
Apologies if this is kind of a more convoluted one. It's more about the practice rather than just, printing as a whole.
Mm-hmm.
But I'm also asking, say, console debugging in a lot of, I guess, game software like this in particular. How would you prepare your code beforehand? Or how would you know what you want to be shared with you beyond just a single variable? If you need to go into, say a console and see exactly what were to be wrong. Or, how do I word this?
Are you asking how you would debug a program?
How do you prepare your code to be easily diagnosable?
That is definitely a very loaded question that we could get into for a very long time. At a high level, since you're having since it seems like coming from a little bit of background on this, what we would usually try to do is we would want our variables to be fairly readable. Like, for example, value is really not an example of a good variable. And I fully admit that it's not an example of a good variable. So, like, for example, this is a squiggly line. So I admit, like, for example, value, not exactly the best name for a variable, right? So, like, if I was going through a larger program, what I would be wanting to do here is I would be wanting to have something that was a lot more specific, right? Like, I would be like, for example, if it was a game, I might have a variable that is like that is named world, and and if it's a player, I might have something referring to player, right? Or if it's referring to objects in the world, I might be more specific on exactly what I want it to be. Like, variable name is very important to readability. The other thing is also things like length of the code is very important to readability. So one of the fun things about a debugger or console logging whenever you are going through a debug process is, in general, the more crystal clear your variables are, the easier it is to just put a print statement in, put a log statement, or put what we refer to in industry as a debugger, which will stop your program right at the execution. We're not going to touch how to use debuggers for this, for the purposes of this course, because personally, they're a bit overkill for the problems that we're trying to solve. But if we had a really, really complex problem, like, say, something in a game engine, we would stick a debugger in, and we would be able to see every variable, every state, and everything that is currently going on within the program. And if our individual functions, like, for example, the function that's built in for Python called print is pretty self-explanatory on what it does, which is good. It's readable. It's easy to understand what it does. If I were to create my own functions, and in this case, a function is something that takes an input and performs an action, right? If I were to create my own functions, then I would want it to do roughly, I would want it to be named in such a way that I can look at it and see at a glance what it is. There's an entire school of thought on clean software design and readability and all that, and there's an entire technical discipline on it referred to as like software engineering, right? And in some universities, there are even dedicated courses offered specifically on how to properly design a program that is readable. And we do touch a little bit on best practices and the like in this course. We definitely don't start with it because it will, don't want to throw too much at everyone, but hopefully that answers your question a little bit. Glad I could help. All right. We got about, well, anyone else have any questions? Best language for new people. I'm going to lean towards Python. And the reason I'm going to lean towards Python is you can accomplish a lot with very few lines of code. It is very well documented. It has a fairly large community and as well as a large number of resources to work with. What you don't want if you're a newer programmer or a newer developer is you don't want to be digging into languages that are really esoteric. And by esoteric, I mean they don't have very many people who are using them. They haven't been around a very long time. And in general, they're going to be very difficult for you to dig in and find out, right? Like, there's some really cool new languages. I've definitely played with a few. They take me 2 to 3 times as long to learn as something that's well established because there's not the information for that. In some cases, they don't have any documentation. So, like, the reason like we chose Python was because it is very accessible to newer programmers, right? There are other languages that are commonly used for introductory programming as well. Believe it or not, Java is still used in some areas. Not going to do that because it immediately throws an entire different programming concept at you, but it is also a commonly used one. Yes, that is also a big one. Yes. But yeah, really good question. Genuinely. I would add the note that in general, the language you use is less important than what you actually end up building at the end of the day. So, like, it's very easy to end up in a situation of, oh, should I learn this, or this? Eventually, it's like, learn what makes the most sense at the time, then start building it. And if you're wrong, you learn something. If you're right, well, you still learned something, and you got something cool out of it. Is a game engine hard? Yes. It's okay, so correct, yes. You can write. I've written a game engine before, and there are a few peers of mine who have done the same. It's a fun learning experience, but end of the day, it's usually there are cases where you would want to build one, but if you're asking the question of whether or not it's difficult, I think the best way to explain it is there are several companies whose entire business model is just building these engines for other developers to use, largely because they take a lot of time and a lot of very specific expertise and the like. And when positions for software engineering are placed, for someone to work on a game engine, they will be tailored specifically for the game engine in many cases. It's very difficult. It's very specialized work. Not going to discourage anyone from trying to do it. I'm just saying it's very difficult.
I have a question.
Yeah, go for it.
Speaking of Java,
Mhm.
will there be much conversation about other development environments than just Python?
It's definitely so. The primary focus is Python. Definitely welcome conversations about other environments or other languages. The bulk of the course is taught in Python. I'll be honest, if you decide to write something in a different language, I will still grade it if it works.
Right.
And if it doesn't work, there's a good chance I already know the language anyways, and I can point out to you what's wrong.
Okay.
So, yeah.
I have another question.
Go for it.
So I say this as someone I say this as someone who comes from mostly working in C#. I've heard a lot of people who are either on the side of Python is the best language to work in, it's the most, most well documented, etc. But I also hear an equally loud majority of people say Python is one of the worst. Are there any particularly negative traits about Python that stand out just as a introductory kind of thing? What you should be looking out for?
It's a really good question. The indentation is something that tends to catch people up. So in Python, it doesn't have braces, so it doesn't have it doesn't have braces for your code, right? So like, for example, if you write an if statement, you don't write braces. You end up just doing indentation. The indentation, like, tab in to verify that you are inside this code block, right? If you forget to do that, then you'll end up with some very interesting errors, ranging anywhere from this variable did not assign correctly to this entire thing just crashed. But that's really the only gotcha in my experience that really tends to catch people up. And It's definitely a fairly common one. The counterpoint to that is, in the case of Python, is really you should be formatting your code anyways with proper indentation. Most of the time it's right click, click format in your text editor to do it. So, I mean, I personally don't see that as too big of an issue, but I can definitely see it if you're not very familiar with programming that it would cause that issue. For me personally, my first languages being like C and C++, right? We always had to put those brackets in and sometimes you just forgot to indent your code because you didn't know any better. Python kind of slaps you on the wrist when you do that. But I mean, it's a very clear-cut error. Like, what it'll do is most of the time it'll just crash the minute you run it. So you'll know pretty quick, oh, this is formatted wrong. And yeah, everyone has an opinion about a language. It's good and bad. Like, you know, strengths and weaknesses, different tools for the job. Yeah. Yeah. That too. Yeah. True equals 1 is the one I found people get confused with. Yeah. Booleans are weird. And some languages will just simply let you do a comparison between the two or switch between the two. I've also seen some people switch in their code. I've seen people actually switch 1 and 2, even in... I've actually seen people even switch that, and I'm like, why did we just redefine true and false? But yeah, no, that is definitely something that catches people up. Python has that problem. JavaScript has that problem. I want to say most duck-typed or loosely typed languages have that problem. So, like for example, here you'll notice we're not saying what this has to be, right? We're just saying this is the name of our variable. In some languages, we would have to define what the variable actually is, and we'll get into types later. Oh, go for it. Apologies.
Yeah, that's exactly what I was about to say.
So, at an extremely high level, int is a type. So, we would have to define that it is of type int in these examples, at least for the first 3. So because we're in Python, we don't have to define that. It's a little bit easier to go through and write code with. Some people love that. Some people hate that. That's part of where the comparison between, that's probably one of the complaints some people have about Python, is the fact that you don't have to define that. But we do end up touching on types in a bit more detail. I believe that's week 2 or 3. I'd have to double check the syllabus. But yeah.
One last question from me, sorry.
Yeah, go for it. No, you're completely fine.
Could you define what you mean when you say high level? Because, you know, obviously high level, we have like low level where it's like very close to the actual processor, but a lot of people think high level is in like high experience level. So could you define what you mean when you say level?
Yeah, absolutely. Yeah, absolutely. By high level, what I'm referring to in this case is we're going to touch upon the basic concepts. Like, we're going to touch upon enough theory that you can get a working program, but we're not going to touch upon the bits and bytes of exactly how the processor works or how the data is represented. Like, for example, we're not going to touch upon 8 bits in a byte. Like, that's something that's very low level that we're not going to touch on. And for those of you in the audience who do know what I'm talking about, congrats. Those who do want to know, feel free to ask and I'll happily explain it. But that's an example of something that like we're not going to, because we don't need to know that level of detail in order to write a program, we're not going to be touching it in this case. Good question, though. All right, let's see. You got any more questions? Oh, Roy, we're probably good to call the stream here if you want. Been a pleasure, everyone.